Welcome to Thorlabs. My name is Matt, and today I'll be discussing how to start a new Visual Studio project and how to write a program in C# that initializes and moves a stage connected to a Kinesis motor controller. For this demonstration, I have here a Kinesis benchtop brushless motor controller and a 2-axis stage. Before we get started, it is recommended that you verify that you have an appropriate version of Visual Studio and the .NET framework installed on your PC. Kinesis is built targeting version 4.5.2 of the .NET framework, so you will need a development environment suitable for this. In our case, we're using Visual Studio 2019. And now with Visual Studio open, we can hit Create a New Project, select the template for a console application targeting the .NET framework, and when prompted, enter a name for the project. Here we're going to use the name Insight Application. Hit Create. And you should see the code editor. Once this is open, we can configure the project to use the Kinesis libraries. First, we'll want to navigate to the project dropdown, select the properties, and head over to the build section. Here we want to update the platform target to match the bit version of the Kinesis libraries we're using. On this PC we have Kinesis 64-bit installed, so we want to target an x64 application. Save the settings and close the properties window. Next we need to add the Kinesis DLLs to the project. So on the right side of the screen you should see the Solution Explorer menu. Right-click on References and hit Add Reference. Browse to the Kinesis install location. For 64-bit Kinesis, this is under the C drive, Program Files, Thorlabs, and Kinesis directories. From here we want to select 3 DLLs. The benchtop brushless motor CLI, the device manager CLI, and the generic motor CLI. Hit OK to add these to the project, and you should see them pop up in the references section on the right. Now would be a good idea to build the project to make sure everything's working properly so far. So hit Start at the top of the window. You should see a console pop up and then immediately disappear. We can now check the directory where our solution is being stored. Head over to the debug folder, and now we should see the DLLs we've selected as well as a few other dependencies that get copied at runtime. In addition to these DLLs though, we also have some C-based dependencies that need to be copied manually. So head back over to the Kinesis install location, and we want to select the device manager DLL and the brushless motor DLL. Copy these to the build location. And at this point our project is set up and we can begin writing our code. We can start by adding the references to the device manager CLI and the benchtop brushless motor CLI. And then in the body of the program, we can start by calling the build device list method from the device manager CLI. This method loads all available controllers into memory and makes them accessible to our program. And this also should be surrounded by a try-catch block to handle any errors thrown by the method. For those that aren't familiar, a try-catch block is a section of code that instructs the program what to do in case an error is thrown by a method. In this case, we want to catch a generic exception thrown by the build device list method. And if an error is caught, we'll write that to the console and terminate the program with a return. If we then wanted to check which devices are connected to the PC at this time, we can create a new list variable, and we can assign this using the getDeviceList method, also from the Device Manager CLI. This method returns a list of strings that contains the serial numbers for all the connected devices, and if we wanted to further filter that list, in the case that we have many devices connected, we can pass an integer to this get method. This integer would correspond to the first 2 or 3 digits of the serial number of your connected controller. In our case, we're using a 300 series benchtop brushless motor controller, so our prefix is 103. Now, before moving on to the initialization of the controller, it's good to check that this getDeviceList method did indeed find the expected devices. To do this, we're just going to set up a simple if-else statement that checks that the size of the returned list is greater than 0. And if it is greater than 0, we'll print the found serial number to the console. In this case, we're just using the first index of the list, which corresponds to the first found device. And in the case where there are no serial numbers found, we're going to write this to the console and then terminate the program with another return. Here would also be a good idea to run and build the project to verify that our serial numbers do indeed populate. So let's hit start. A console should pop up and our serial number is printed, so we know that it's working properly. And with our serial number detected, we can continue on to initialization. Now, initialization for the Kinesis benchtop controllers happens in 2 steps. First, we want to connect to the chassis, and then from this, we want to connect to the individual channels. So we can start chassis initialization by creating a new benchtop brushless motor variable. We'll call this controller. And we'll assign this controller variable by calling the create benchtop brushless motor method from the brushless motor CLI. And this method takes the serial number as an input. It's also a good idea to check that there were no errors when calling this create method. If an error is thrown, then the controller variable might not be initialized properly. So we want to use an if statement to check that this is not null. So if the controller variable is not equal to null, we can continue. And from here, we want to call the connect method, followed by the get motherboard configuration method. Now, both of these methods act as the initialization for the chassis. They both take the serial number as an input, and the get motherboard configuration method takes an additional parameter that corresponds to the way the controller is going to load settings. Here we're using the use device settings parameter, so this says to use any defaults in the controller. And with the chassis initialized, we can move on to channel initialization. So let's create a new 300 series brushless motor channel variable. We'll call this channel. And this will be assigned using the getChannel method from the controller variable. And you'll also want to cast the return from the getChannel method to the brushless 300 motor channel type. Again, let's check if the return of the getChannel method was correct, so we can use another if statement and check if the channel is null. And as long as the channel is not null, we can move on with initialization. Now the next part of the initialization sequence for the channel involves calling several different methods. We'll start by calling the connect method. And this takes the serial number. And this is followed by the wait for settings initialize method. And this takes a timeout value as a parameter. Now what this method does is it allows for any settings to be loaded on a background thread, and it'll wait for that to be finished before continuing. And then this wait method is followed by the load motor configuration method. This takes a device ID that's stored in the channel of the controller, so we call the device ID parameter from the channel variable. And this method serves a similar purpose to the get motherboard configuration method that we used previously. This will take any stage defaults and load them to the controller. At this point, it's also a good idea to call the start polling method. Now what this method does is it starts an update loop within the controller, and each time this loop cycles, it will make any position and status information available to the user. And after calling the start polling method, we need to add a small wait that gives the controller channel an opportunity to check any enable states or statuses. And we'll do this by calling the sleep method from the system.threading.thread class. Right after the sleep, we can call the enable method. We'll add another sleep, and this lets the enable state update in the controller. Now to make the final program a little bit neater, it's a good idea to create any move helper methods. And just to show how this would be done, I'm going to create two methods called home stage and move stage. Both of these methods are going to take a brushless motor channel as an input, while the move stage is going to take an additional parameter that represents the target position. The home stage method should start with a try-catch block surrounding the home method from the channel. Now this will help us handle any possible errors that are returned from the stage moving. And here we're just calling the home method, passing an integer representing the wait timeout, and we're catching a generic exception. Now the wait timeout passed to the home method indicates how long the controller is going to wait before throwing an error. This error would signify that some problem was encountered while completing the movement. However, if the move completes within this time, then it will return and move on to the rest of the code as normal. And in the catch block, let's just indicate that there was a problem if we see one by printing to the console. And just to show program flow, let's add a few print statements around the home method. Now the move stage method will be set up in almost the same way, except the home is going to be replaced by a move to method, and will use the position parameter that we pass to this method. Now the move stage method will be set up in the same way. So let's create our try catch block. Catch the generic exception. And in the same way as the home stage method, we'll add a few print statements to show program flow and call the move method. And in the catch section, let's add another print statement to show that there was an error. Now with these methods done, we can finish up the main body of the program. So go ahead and start by calling the home stage method. And at this point, it would be a good time to adjust any velocity settings for the stage. So to demonstrate this, I'll use the setVelocity parameters method on the channel. And this method takes two values corresponding to the max velocity and the acceleration. Now the units of these parameters is dependent on the type of stage you're using. Here we're using a linear stage, so our units are going to be in millimeters per second and millimeters per second squared respectively. For this demonstration, I'm just going to use 5 millimeters per second and 100 millimeters per second squared. So now let's call the move stage method a few times. Here I'm going to use two moves, the first one going to 110 millimeters. And the second one going to 55 millimeters. And then from here, we can begin the disconnect sequence for the controller. For the channel, we start this by calling the stop polling and then disable methods. And then for the controller, we could just call the disconnect method. Now this method takes a Boolean, and this represents the shutdown sequence that will be performed when this method is called. We're passing the value false, and this will tell the controller to not fully shut down, and instead it will be available to reconnect if we wanted to within the same program. Let's add one last print to console to indicate that the controller disconnected. And then we're ready to test our code. So hit the Start button up top, and let's check what our program outputs. So we see the serial number is printed first, and this is followed by any debug information. Our home method is finished, and now our first move is starting. And that finished, and now our second move is starting. And now that that's done, it'll begin the disconnect sequence and then close the console. I hope this helps you with your application. If you have any questions, feel free to contact tech support.